Sir, is it 50?
NH2, CO, NH2. First, do you know what is the form? What is the name of NH2, CO, NH2? Anyone?
CO, SO4, right?
Sorry. What do you say?
Nothing to got interesting.
For nitrogen, it is a 14. Hydrogen, 2. Carbon, it's a 12. For oxygen, it is 16. Next, 14 plus 2. How much? 30. 42. 56.
60, sir.
60, right?
Yes,
Yes,
sir.
sir.
60 grams. It is clear. Molecular mass, atomic mass. What is atomic mass?
Yes, sir.
What is the definition of atomic mass? Vedika, have you seen the last video?
Yes, sir.
Then tell me what is the definition of atomic mass?
N- Atomic mass is number of times the atomic mass is number of times of an atom. Yeah, of an atom. Yes.
Atomic mass is the number of times of an atom. Okay. Then turn on your videos, everyone. Jivika,
Yes, sir.
what is atomic mass?
Atomic mass is the number of times an atom of an element is heavier than 1/12 of an atom of C12 isotope.
Number of times heavier than the 1/12 of the C12 isotope. Then what is the AMU, Ananya?
It is defined as a mass exactly equal to 1/12 of the mass of one C12 atom.
It is a mass exactly equal to the 1/12 of the fraction of the C12 isotope. Piyush?
Yes, sir.
Yeah. What is the mass of the what is the value of one AMU?
Yes, sir. The mass of an AMU is equal to 1/12 of a carbon 12 isotope.
No, the value I'm asking, numerical value.
Yes, sir. 1 minute. So 1 second.
Yeah.
So 1.66 to the power 10 to the power minus 26.
1.66 056 into 10 power minus
26.
it's not 26.
Sir, I know.
Okay, yeah, it's 27. Sorry, sir.
Yeah. Next, Jivika, is it correct?
Sir, it's 1.66056 into 10 raised to the power minus 24
Minus 24. It's a kg or grams?
grams.
Grams. It is in the kgs. It is a minus 27. 1.66056 into 10 power minus 27 grams. Sorry, 27 kgs. Okay. What is the average atomic mass? Kavya? What is the average atomic mass, Kavya?
Sir, are you speaking something?
Is it clear or not till now for you?
No, sir, it's clear, but I cannot hear you properly, you know.
Sir, you're audible.
Okay. What is the average atomic mass? Pranav?
Yes, sir.
What is the average atomic mass? Ananya?
Yes, sir.
Yeah.
The
What is?
sum of percentage of abundance into isotopic mass by 100.
If you are considering the all the isotopic masses for the calculation of atomic mass, that is a average atomic mass, right?
Yes,
So
sir.
summation of the percentage abundance of each isotope into the isotopic mass divided by 100.
Sir, can you once explain this?
Average atomic mass, Ananya.
Sir, not me, Vedika.
Sorry, Vedika.
Yes, sir, that was not in the recording.
Okay. See, can you see the formula?
Yes, sir.
So average atomic mass is equal to the summation. The symbol is called as a summation of percentage abundance of isotope into isotopic mass by 100. This is a formula.
Okay, sir.
Okay. Now suppose if you take the example like, listen here, Vedika. If you take the example like chlorine. Chlorine has a two isotopes. One is Cl35 and Cl37. What is this 35 and 37? These are the isotopic mass. Okay. And their
Okay, sir.
percentage abundance of each isotope is given as 75% and the 25%. Cl35 is abundance, percentage abundance is 75%, and Cl37 percentage abundance is 25%. Find out the average atomic mass of chlorine. So we'll apply the formula. Average atomic mass of chlorine is equal to, I'll write down once again here. So for this is the first isotope, Cl35. According to the question, second isotope is Cl37, right? So what is the first isotope?
Yes, sir.
Abundance 75%. Second one
25%.
25. So average atomic mass is equal to summation of percentage abundance into isotope mass by 100. What is the first isotope here? Chlorine 35, 75%, right?
Yes, sir.
Then what is the percentage of abundance? 75 into what is the isotopic mass here?
35.
35. Finish this one, first one. First
So
one we added
2625.
plus summation, right? You have to add all the isotopic masses. So summation means this is a plus. So plus, what is the second one?
25 into 37.
Into 37. Overall divided by 100. So if you do this one, how much you'll get?
35.5.
You'll get 35.5. This is the average atomic mass of chlorine. Understand now?
Yes, sir.
First, what is the meaning of isotope? You are saying every time isotope, isotope and all. Everyone? You're saying the isotope, right? What is the meaning of isotope first?
Having same atomic number but different mass number.
Isotope means it has same atomic number but different mass number. Okay, then why it is having the different mass number? Which one will change? Whether proton will change or electron will change or neutron will change?
So I think neutrons.
Very good. In the case of isotopes, each and everyone will have a different number of neutrons. You take example, carbon, C6, 12, 13, sorry, 12, C6, 13, C6, 14. So all will have the same protons and same electrons, but it has all will have different number of neutrons. So in the isotopes, the number of neutrons are different from each other. Understanding?
Yes, sir.
Yes, sir.
Whether
Yes, sir.
all the three isotopes will have the same chemical properties?
No, sir.
Yes or no?
No.
No.
Sorry,
No.
yes. They have same chemical properties, but different physical properties.
Okay. Can you know the reason? What is it behind that same chemical properties?
Because they all are only carbon atom.
Because they are only carbon atom. Okay. See, one thing we studied, right? Valency electron concept.
Yes, sir. Number of
Yes.
electron in the last shell.
Number of electrons present in the last shell. So for any bond formation, which electrons will involve? Either valency electrons or inner electrons.
Valence electrons.
Only valency electrons will involve. So the chemical properties of the isotopes will depend only on the electrons. Right? If you take any
Yes, sir.
chemical properties of an element, it will depend only upon the valency electrons. It will not depend upon the neutrons at all. So if the number of neutrons changes also, it will not affect the chemical properties of any element or any isotope. Understanding?
Yes, sir.
So all the isotopes will have the similar chemical properties only. But physical properties will vary, but chemical properties of all the isotopes will be same because of having the same number of electrons. So because of having the same number of electron means the number of electrons is equal to number of protons only, right? In the case of neutral atom.
Yes, sir.
So the chemical properties will depend only on the electrons. but electrons will depend upon the protons. But neutrons has no effect at all in these cases. So all the isotopes will have the same chemical properties. If you say any bond formation, only the valence electrons will involve in the bond formation. Okay, in any element. What is the meaning of innermost electrons?
The number of electrons in the inner shell, in the K shell.
So other than the valence electrons, remaining all electrons are called as an innermost electrons. Okay,
So is it inner or innermost?
inner we can say. Okay, innermost means the K shell. Okay, no problem. Inner electrons it will say. Both terms are common in chemistry. Inner will say, innermost will say.
Okay, sir.
So outside only we'll remove now that valence electrons. Remaining other than the valence electrons, remaining all are inner electrons or innermost electrons. So these innermost electrons will not participate in any bonding. First thing. All isotopes have the same chemical properties due to having same number of electrons. Then can you say some more examples? Isotopes. Hydrogen. Have seen this?
No, sir.
Hydrogen, deuterium 1,2, tritium 1,3. These are hydrogen isotopes. Chlorine, halation, we have seen the example. So these are the common isotopes.
There is even iodine isotope.
Sorry,
Is
Iodine.
iodine a isotope?
iodine, I think so. No isotopes. I'll check it and I'll tell you. Okay.
Yes, sir.
So these are the common isotopes we are using in the chemistry. Iodine, we won't go that much of far. Okay, these are all about the isotopes. Next one is the isobars. What is the meaning of isobars?
So mass number would be same, but the atomic number will not be same.
It has same mass number, but different atomic number. Any examples? Any examples for the isobars?
Sir, I think argon and calcium,
Yeah,
they both have 40.
good. Argon 1840 and calcium 2040. So the substance will have the same mass number, but different atomic numbers are called as an isobars. Potassium also almost having the same only. If you take potassium 1940, also one of the isotope. Then
So
what is it?
chlorine?
Chlorine will not have. chlorine has 1735, right?
Yes, sir.
Or 1737 only. There is no 1740 isotope in the chlorine.
Okay, sir.
Okay, what is the difference between in the case of isobars? Which one will be different? Proton, electron, neutron.
So the electrons and protons.
Isobars has a different number of protons as well as electrons. Yes or no? Because the atomic number is changing. What about the neutrons?
They'll be the same.
They will be the same. Next one is the isotones. What is the meaning of isotones?
I think both mass number and atomic number would be different.
Anyone? In this case, the number of neutrons are same. In the case of isotones, only the number of neutrons are same. The remaining will change. The elements which have the different atomic number and mass number. But have the same number of neutrons. Understanding? Isotones means which will have different atomic number and different mass number, but only the common thing is they have the same number of neutrons. We take example like nitrogen 715, oxygen 816. How many protons, electrons, neutrons are there in this case? 7, electron 7, neutron 8, right?
Yes, sir.
In this case, yes or no?
Yes, sir.
So in both the cases, only the number of neutrons are same. What about it? Wait a minute. C614. In this case, how many neutrons are there?
So what did you say, sir?
Protons 8, electrons 8, the neutrons. What about the neutrons?
So 8.
8.
It's 6.
So all are same, right? 1 minute, please. Yeah. Clear?
Sir, in carbon, shouldn't the protons and electrons be 6?
Sorry.
Yeah, sir.
Sorry. 6. Okay. So protons, electrons will be 6, and the neutrons will be 8, right?
Yes, sir.
Understand? Isotones? Or any doubts?
Yes, sir.
No doubt, sir.
Then what is the meaning of isoelectronic species? First, what is the meaning of iso? Every time we are saying iso.
There's a different variation.
Iso means same, right? Similar. What is the meaning of isoelectronic? Anyone? The chemical species in which the number of electrons are same. The chemical species in which the number of electrons is same. Are called as an isoelectronic species. Understand? Only the electrons will be same in this case. That is called as an
So only ions. So only ions can
form the isoelectronic species. Your doubt?
yes, sir.
Yeah. Suppose if you take neon, how many electrons will be there in this? Ten electrons, right? According to
Yes,
atomic
sir.
number. What about F?
10. 9, sir.
9. If you add F minus 1,
So 10.
Sir,
10.
10.
Oxygen
8.
minus 2.
10.
8. 10.
Nitrogen
Nitrogen.
7.
7 minus 3.
10.
10.
Sodium
11, sir.
11.
plus 1.
10.
10.
Magnesium.
12.
Understand? Now in all these cases, we have the same number of electrons, right? Yes or
Yes,
no?
sir.
But except the neon, Ananya. So it can't be always ions, but most of the case it is ions only. Except noble gases. Because noble gases
Okay.
cannot form the ions, right?
Yes, sir.
So remaining all will form the ions only. So isoelectronic species means what? The species in which the number of electrons are same is called as an isoelectronic species. Clear?
Yes, sir.
So is there any doubts in that? What are the different topics? Isobars, isotopes, isotones, isoelectronic species. So
No
generally,
doubt, sir.
when you're remembering these one, remember with the examples. That is a better way of remembering. So don't get the confusion after a long time. Suppose if you take isotopes, remember with the example. Because all will have the same only, right? Only the changing is mass number, atomic number, or atomic number, mass numbers. Understanding? So if you remember with the examples, now you will not have confusion, these confusions. So isotope example. What is the example for isotope?
Carbon 12, carbon 13,
Carbon.
carbon 14.
Carbon 12, carbon 13, carbon 14. Isobars,
Potassium and
Sir, argon and calcium.
argon, and the calcium. Very good. So what is the definition of isobars?
It has
Yeah.
same mass number,
It
but
It has same
different
mass
atomic
number but different atomic number.
It has the same mass number, but
Different atomic number.
different atomic number. Next one, isotones.
Nitrogen, oxygen, and carbon.
nitrogen,
Hydrogen 15.
oxygen, and the carbon.
And its neutrons are same.
It will, in this case, the number of neutrons will be same.
Same.
And the last one is the isoelectronic. Isoelectronic means the chemical species in which the number of electrons is same. Clear?
Yes, sir.
Pranav?
Yes, sir.